This video is all about 11.2, which is going to be the volume of a prism and a cylinder. Again, you're going to have a quiz after sections 11.3. So what does it mean when you find the volume? Okay, volume, unlike area, volume is the amount of space an object takes up. So right underneath that in blue, you can see, can you find the volume of a two-dimensional figure? And the answer there is no. Okay, volume is measured in 3 dimensions. Okay, we measure 3-dimensional space. If you have something that's 2-dimensional, obviously, I just said it has to be 3-dimensional to find the volume. So if you only have 2 dimensions, you can't find the volume of that figure. So again, the volume is the space that a figure occupies, and it's measured in what's called cubic units. So again, if you think about the word cubic, 2 cubed, it's to the 3rd power. So again, you're multiplying 3 things together. This 2 has nothing to do with the problem itself. I'm just talking about the cubic here. Okay, so that's raised to the 3rd power. So you're multiplying 3 things together. Okay, so to find the volume of any sort of prism, we're going to use a very general formula. It's going to be base times the height. And notice that this base has a capital B. Okay, what does that mean? If it's a capital B, that's going to represent the area of the entire base. And the H is always just going to be the height of the figure. So again, your prism can have a different shape for its base, as you see in the 2 pictures here on the right. One of those, that's either a rectangular prism or a square one. Okay, it's either a square or a rectangle on the bottom. You'd have to find the area of the square or the rectangle first, and then multiply it by the height. In the right-hand one, you have a triangular prism. Remember, keep in mind with the prism, your bases are the sides that are parallel. So again, it's your triangular sides here that are parallel. That's why even though this is sitting on a rectangle, it's still a triangular prism. Okay, so we would find the area of that triangle by doing the regular old area of a triangle formula, 1/2 base times height, and then multiplying it by that height. So the volume of any old prism, the area of the base times the height. Okay, and if we have a cylinder, pretty much the same thing is going to hold true, but your base of a cylinder is always going to be a circle. So again, if we went back to volume equals base times height, this time the base is a circle, and the area of a circle is pi r squared. So that's why we have the pi r squared h there. Okay, so a cylinder is always going to be pi r squared h, but again, directly related to volume equals the area of the base times the height. So again, as always, we'll just do some straightforward examples first before we take it a step further. So we want to find the volume of each, and we want to round to the nearest 100th when necessary. So 2 spots after the decimal. Okay, so this is a rectangular prism. So the area is going to be the volume is going to be the area of the base times the height. This base is a rectangle. So we're going to say that the volume here is going to be, I'll take out that base and put in the area of a rectangle, which is length times width, and then bring down the height. Okay, so multiplication here is commutative. So technically it doesn't matter how we plug these in. So really we're just going to do 2 times 3 times 6. And when you do 2 times 3 times 6, you should get an answer of 36 there. For part B, you have a triangular prism. And again, if we start with volume equals the area of the base times the height. Again, first let's talk about the area of the base. Again, the base is a triangle. So the area of a triangle is 1/2 little b, the base of the triangle, times the height. Okay, and then we're going to multiply that by the height of the prism. Okay, so let's talk about our triangle first. Okay, so our triangle here, let's look at the top one because it's labeled. Okay, the base and the height of that triangle, since it's a right triangle, the 9 and the 12 are going to be the base and the height of the triangle. So volume is going to equal 1/2 of 9 times 12. And then I need the height of that prism, and the height is over here. It's that 5. Okay, so before I go and multiply, just notice that this 15 never came into play. Okay, a lot of times they're going to give you an extra piece of information, and you are going to have to know to ignore it. Okay, sometimes you might be missing a piece and you might have to find it, but one way or the other, just because they give you something doesn't necessarily mean it's going to go in the formula for the volume itself. So when you multiply here, again, please play along on your calculator. You should get an answer of 270. So the volume of that triangular prism is 270 there. For part C, This is technically a cube. What's the difference between a cube and a rectangular prism? All the sides are equal. So again, the volume is going to equal the area of the base times its height. Okay, or again, you can either say side squared for the square on the bottom. You can say length times width, whatever you want. Length times width times height. But again, they're all the same here. So 8 times 8 times 8. Or again, if you wanted to do that in a simpler way, you could say 8 cubed. Either way, when you multiply there, you should get an answer of 512. Okay, and here is our cylinder. So again, whether you want to memorize it or not, you can still go back to the area of the base times the height. And again, our circle is our base. So the area of a circle is pi r squared. And then we're going to tack on the h in the end here. Just be careful because that 11, it represents the entire diameter of that circle. We only need the radius. The radius is half the diameter. So when you divide 11 by 2, you should get an answer of 5.5. So your radius is going to be 5.5 here. So we'll do pi times 5.5 squared, and my height is 16. And again, if you were to go back to the top or look at the top here of the directions, it said round to the nearest hundredth. So we're going to do 2 spots after the decimal. And wouldn't you know, I only have 1. I don't know if it came out to only a tenth or not. I only have 1 on my sheet of paper. So just double check. I'll do it to the nearest tenth. It might be that's the real answer, or I might have just screwed up and not put the extra decimal on there. But when you do that, you should get an answer of 1,520.5. And of course, now we're just going to take this a step further because, again, you have seen volume before. Hey, and we're going to talk about something called an oblique prism. So what's the difference between an oblique prism and a right prism? Again, with a right prism, your height is going to be perpendicular to the base. With your oblique prism, it's like the Leaning Tower of Pisa. Okay, so again, you can see here in the color, both stacks contain the same number of papers. So you have the same number of blue papers on the left, blue papers on the right. Same number of yellow paper on the left, yellow paper on the right, red, red, green, green. So we have this thing called Cavalieri's principle. And what that says is if 2 figures have the same height and the same cross-sectional area at every level, then they're going to have the same volume. It's easy to think about when you think about the paper concept up here. Hey, if you took the oblique prism and then just smushed it and made it so all the papers were stacked perpendicular to the table, you would end up with the picture on the right. They would clearly have the same volume. Okay, so again, and then if you take one sheet of paper off that right-hand side and one piece of paper off the left-hand side, they're going to have the same cross-sectional area. The area of the rectangle is going to be the same at every single level. So it's pretty easy to think about it in terms of a paper concept. Okay, so again, the one down here, again, we have 2 figures have the same cross-sectional area. So if you have a cone and a pyramid, it's possible that they have the same areas as well. Okay, so we're going to use Cavalieri's principle to explain why the volume of those 2 cylinders are always equal. So again, they have the same exact height. Okay, and the radius here is 5 and the radius here is 5, which means the area of the circle at any level would be the same because your radius is the same. So they have the same height. And the cross-sectional area at every level is equal. So a shipping container is in the shape of a right rectangular prism with a length of 108 inches, a width of 78 inches, and a height of 4 feet. The container is completely filled with contents that weigh on average 0.25 pounds per cubic foot. What is the weight in pounds of the content in the container? Okay, so the first thing that we have to do here, notice that this is per cubic foot, this is in feet, but then these two measurements are in inches. So the first thing that we need to do is change those two things to feet first. So since there's 12 inches in a foot, okay, I'm going to take the 108 and divide it by 12. That should give me an answer of 9. So it's really going to be 9 feet. And then our other one was 78. And if I take 78 and divide it by 12, that's going to give me an answer of 6.5 feet. So in terms of feet, we have a 9 and a 6.5 instead of your 108 and 78. Okay, if it is a rectangular prism, again, the area of the base is going to be a rectangle. It's going to be length times width. So again, the volume then, take that area of the base, length times width, and bring down the height. So it's going to be length times width times height. So again, when we calculate that, just please make sure that you're doing everything in terms of the feet. So we're going to have the 9 feet, the 6.5 feet, and our other one was 4, and it was already in terms of feet. So we're going to do 9 times 6.5 times 4. And when you do that, the volume is going to be 234. So far I have the volume, but it's asking me what the weight is. So the weight, if 1 cubic foot weighs 0.25 pounds, and I need to know how many 234 of those weigh, all I'm going to do is multiply this by 0.25. And when you do that, you should get 58.5 pounds. So that box will weigh 58.5 pounds when it's filled. Okay, so we want to find the volume of each figure here. There's 3 figures on this slide. Okay, so for part A, you have an oblique prism here. Again, it's like the Leaning Tower of Pisa. But again, what Cavalieri's principle says is if you took that and straightened it out, it would have the same exact volume as if it were a right prism. So again, we're still going to use this area of the base times the height in order to find the volume. And again, that big B matters. Okay, on the bottom, you have 1, 2, 3, 4, 5, 6. There's no formula to find the area of a hexagon, but notice that they put the big B up here. That is the area of the base. So you don't have to find the area of the base here. They're telling you what that is. Okay, and then our height is going to be over here. So to find this volume, very simply, all we're going to do is 17.3 times 6.4. And when you do that, you should get an answer of 110.72. Okay, for part B here, again, this is a trapezoidal prism, again, because it is named for the 2 sides that are parallel, and your parallel faces here are in the shape of your trapezoid. Okay, so again, if we're doing volume equals the area of the base times the height. The base is a trapezoid, so if we want to find the area of a trapezoid, it's going to be 1/2 times the height of the trapezoid times base 1 plus base 2. And again, then after we do that, we'll multiply it by the height of the prism. So we're concentrating on, in the figure, what I highlighted in the purple there. So I'm going to have 1/2. The height for that trapezoid is that 4. And base 1 and base 2 here. I'm sorry, that's not the height. I don't know why I put that under the height. That's one of the bases. Sorry. Redo. Your height is perpendicular, Miss Kudak, always. It's 1.5. Sorry. Okay, and then your bases are the 4 and the 2 there. So we'll do 4 plus 2. Okay, and the height of your prism here is 6. So in the end, we'll multiply that by 6 as well. So again, if you're putting this into the calculator all at once, just please make sure that you're using sets of parentheses. That way your calculator can follow order of operations. Either way that you do it, in the end, when you multiply those all together, you should get an answer of 27. Okay, for part C, again, you have an oblique prism here. And again, it's directly related to your rectangular prism. And again, Cavalier's principle says that we can just take the volume The same way, we're going to find the area of the base and we're going to multiply it by its height. Okay, so the area of the base, we have a rectangle, so it's going to be length times width, and then we'll multiply that by the height. So here I'm going to have 7 times 4, and again, the height, always perpendicular, is going to be 3. So when you multiply 7 times 4 times 3, you should get an answer of 84 there. And that is everything that you've ever wanted to know about the volume of a prism and